Hi guys, we'll continue with our bearing understanding, or the concept of bearing for survey techniques and drafting. Now we skipped over a important point. I did mention it quickly, but I'll go back to it, which is what we call the reverse bearing, and I'll show you now why it's important to us. What the rule about reverse bearing says: if we notice that the bearing was measured or described in the opposite or the reverse way, we should correct that reading. How do we correct that, or how do we choose a reverse bearing? If it was the value of the angle less than 180 degrees, we add 180 degrees. Okay, so I add 180 degrees if an angle was between 0 and 180, so that means it's less than 180. If it was more than 180, we subtract 180 degrees. Simple as that. So let's put it into practicality. What does it mean? Because if I gave you this project, let me just see how can I delete all of those. Close that, don't save, and open it again. Okay, so if I'm drawing this boundary as we agreed, and the same procedure what we were doing before in the previous video, and I got to that point here. I was drawing this line and I got to that point. So let's draw this line here, and then we get to that point. If I go back here, let's take this into Civil 3D. Print screen that area, and simply go to Civil 3D. Let's delete all of those, we don't need them anymore. Paste it here, and as we did before, let's do this to scale one of these lengths so we can get it correctly. So I scale that from any point here with a reference of from this point roughly to that point. I want them to be what, 212.44, 212.44, enter. So that is the right size. Let's move this to the side, and let's say I will start from that point here. Okay, let's call this one here, that point, as our point number 1. Oops, moved it. That is point number 1. Okay, so I'm starting from there. I'll go to polyline and 0 at 0 degrees, starting from there as a starting point, and I'm drawing the first segment, which is 113.92 at an angle of 288 degrees, 53 minutes and 30 seconds. Great, that's similar to what we can see here. Now if I am going to draw this line, that's what I was referring to. So the length of that line is made of two components, 258, 155 all together. So we understand what that means. So this segment here is 258, that's 155, and both of them will be 383. So I'll use that because I'll draw a straight line here. So the length is 383, but the angle is 202.26 and 40 seconds. So based on our understanding, if I haven't realized that this angle here, 202, let's go back to our agreement here, 202, that means it's more than 180, less than 270. So it should be in the third quadrant, which is somewhere here. So it should be a line like that. You see the arrow here? That's not what we're really seeing there. What we're seeing there is a line like this. So that's where I should notice, going back here, I should notice that this should be reversed in bearing. The guys, when they measured it on side, they measured from this point to that point, not the way I'm drawing from this point to that point. If I didn't realize that, and I followed exactly what I'm reading there, so let's draw it, 383.46 at a degree of 202 degrees, 26 minutes and 40 seconds, enter. Sorry, that's 202, not 02. 202 degrees, 26 and 40 seconds. Okay, enter, and that's incorrect. Rather than drawing the line upward, it's drawing the line downward. Therefore, it's important to notice that and say, okay, before I draw it, I'm looking at this value here, this value in the third quadrant. I'm not expecting a line in the third, I'm expecting a line in the second quadrant. That means all I have to do is just reverse the bearing. And the rule about this, as we agreed, I'll go Control Z. Because this value is more than 180 degrees, all I have to do is just subtract 180 of this number. So I just simply 202 take 180, that will be 22. So I'll do exactly the same now. Let's go back so I can read the values. 383, the length doesn't change, 0.46 at a value of 22 degrees, 26 minutes and 40 seconds. Got the format correct and enter, that drew the line correctly. And if I continue here, I find this line 88.46 again in the opposite direction, because 264 is an angle in the third quadrant, less than 270, more than 180. What I'm trying to draw here, if I need to draw something like that, a line like this, that should be in the first quadrant. Straight away, at any point here, let me show you something. At any point, what you should be imagining yourself, you don't need to draw this. Alright, so what you should be imagining, guys, at any point we are drawing, I should be imagining this here. So I got to that point here. That means this line, I should be imagining that shape, and that tells me this line should be, in theory, if I'm drawing this line here, in the first quadrant. But the value they gave me here, it's not in the first quadrant, that's in the third quadrant. Slightly less than 270. So that means I have to obtain the reverse pairing. Let's look at this line next to it, 264 again. That should be in the first quadrant, and again they gave me the wrong bearing, 271, until I get to that point here, which is 173. That's correct. If I measure the angle here, it's about 173, slightly less than 180. So from this line onward, I don't need to do any reverse pairing or change the values. So keep an eye on the reverse pairing, just to make sure in the future that when you see something like this, just any line with a bearing value, try to visualize this shape at the starting point where you're drawing the line from. The starting point of the line, draw this shape in your mind. If you'd like, draw it on the computer as a starting point until you get your head around it. But with time, you'll be more vigilant, and you'll be able to just visualize it without drawing it on the computer. Okay, so that's the concept of reverse pairing. If we find any line that needs to be reverse paired, so if I need to draw, for example, this line again, I'll do one last line. If I need to draw this line here, which is 88.47 at this angle, I have to deduct 180 from this number. So I'll just go here, 264 take 180, and there'll be 84. So I should draw this line at 84 degrees. So if I go back to polyline and starting from here, I'll go 88.47 at an angle of 84 degrees, and 39 minutes. That's it. Sorry, there's 40 seconds, and enter, and that drew the line correctly. If I followed the value I got there, you see how wrong the line, it will be something like that in this direction, 88.47 meters. Okay, so that's reverse bearing. We have to keep an eye on it. That's for the future. When you draw a boundary, you have to keep an eye on these values for the bearing. Now moving on to, as you've seen, bearing with the polar coordinates, what we call them, the polar coordinates, as we agreed, it's referring to, that's the concept of reverse bearing I was talking about. So you have to check your shape before you start drawing. Are they all the same direction, or do we have different directions? If I have different directions, I should reverse some of them so they'll be correct. We said that a traverse is a group of segments, straight segments grouped together. So these traverses, they could form an enclosed shape, as we've seen, and that will create a boundary, for example, closed envelope. We call them closed traverses. Some other traverses, an example is the road traverse, or the longitudinal alignment for the road, or horizontal alignment, is an open traverse. Has a start and an end, and the end doesn't close all the way to the start. It's just an open traverse, a line that stretches between two towns, for example, for the road, or a pipeline. Okay, we worked this example and we talked about open traverses, and this information of the polar coordinates could be given to you in a slightly different way. What we worked on in these two examples that we looked at, that we work on the first point and we draw the point after. Each point will give us, with bearing and length for these segments, we can draw the point after. Some other technique that surveyors sometimes they use, they may put their device in the center of the land and they start measuring to each corner of the block of land a length and bearing. And that will make you always drawing a segment, straight line with a length and bearing always from one point. So that's always your starting point, and you're defining these corners of the block, which is really not used too much, this method, but I thought just to mention it in case you come across something like that. So what you have to do is specify where the 0 point here, which is usually specified, and then from that point you start drawing all these corners, and when you specify your corners, then you can enclose them into a closed envelope. There we go. Now we're going to slightly different coordinates rather than polar coordinates, what we talked about, which is an angle, bearing angle and the length, because it doesn't always give us, as you've seen a minute ago, it depends on the accuracy of the values we're entering. We may have a small error at the end. You've seen it when we drew the first line, the first traverse. Therefore, there's a different way that we use. Both of them are well used, but this is a different way and more accurate way that we use usually with larger projects, which we call it the rectangular coordinates rather than the polar coordinates. Simply based on what we talked about, each line has a bearing angle, and starting from the north, they said, okay, if that's the case, what about this value here, that line, the length and the angle? We divide it into two components from our trigonometry knowledge. We divide it into two components. The length of that line on the vertical axis, we call it northing, and the length of that line on the horizontal axis, we call it easting. So rather than describing the line with a length and an angle, they said, okay, measure this line, multiply by the cosine of this angle, that will give us the length on the vertical axis, that will be northing. Measure this line multiplied by the sine of this angle here, that will give us our easting, or that value there, which is the same as if I draw a parallel line here. We'll call it easting value. So for any point, rather than describing the line now, what I'm describing, if that's 0, 0, that point here, the northing value and the easting value describes the location of the second point. So we call it the rectangular coordinates, simply because that will enclose the shape to a rectangle. how to convert between the two. But just before I move on to converting between the two different coordinates, let me go to, let's start, I'll stay here. Draw some diagrams for you. Change the line to red. Okay. This is not the complete picture for the rectangular coordinates yet. This is a starting point. We said this is north. If that's north, that's south. If that's north, that's east. Always north, east, south, and west. The line I was describing in here, it's located here. If you notice, it's in the first quadrant between the north and the east. That means it's in the first quadrant. It's very important that we are clear on first, second, third, and fourth quadrants. So the line here, as you can see, the north is positive because it's in the opposite, it's in the positive value for north. So north positive upward, as we agreed, vertical upward is positive north. Horizontal to the right is positive east. Very similar to our mathematical coordinates that we use. Y is positive upward, X is horizontally positive to the right. That means any point, the point I'm trying to make here, any point such as this point here has a positive northing and positive easting. Look at it, it's in the positive way. I'll draw this again. Let's say that we have, so that's east and north. In the rectangular coordinates, only what we use, north and east. We don't use south and west at all. That means any point here has a positive north, positive east. Let's look at a point here. Look at this point here, has a negative northing because I went this direction on the north, not in the positive direction, but still has a positive east. So let's call it number 2 in the second coordinates, that point number 2, that has a negative north and positive east. In the third coordinates, let's call it point number 3, look at it, it has a negative east. I moved on the horizontal axis, on the east axis negatively, and still I have negative north. So that's negative north, negative east. In the fourth coordinate quadrant, I have positive north and negative east. Okay? Just important to notice this. Each quadrant has two components, north and east. Any point at any coordinates has two at each quadrant has two coordinates. Simply remember, in the first lecture or video I gave you, I showed you group of points on SketchUp, and these points, they have X and Y components. We said they have, rather than X and Y, we give them, if I draw these points here for any surface, they could be for a surface, for a line, for anything like that. Each one of these points, we said, that has a horizontal and vertical component. The vertical component, guys, it's a north. The horizontal component is an east. Because these points, they could be here in the second or the fourth quadrant. They could be anywhere. So we have to understand that some points will have negative or positive coordinates. So let me go back to, I'll keep this for a minute. Civil 3D, see. Remember I showed you, let's delete those. I showed you the zero. I showed you the origin of the X and Y, or in other words, we have it here north and east. These are your quadrants. Quadrant number 1, quadrant number 2, as you can see the green and red line, that's your origin. Quadrant number 1, any point here, if I enter any point with positive north and positive east, would be in this quadrant. And you can zoom out as much as you want. You've got all of those, all the points here, they've got positive north and positive east. Points here in this quadrant, they have negative north, positive east. In this quadrant, the third one, negative east, negative north. In the fourth one, positive north, negative east. That's important for us to note. Why and how do we use this? Later on, as you see, that will be our starting point. That's how we will define surfaces. So just to show you an example of points that I'm going to import to the software here. So from a surveyor, there you have it. Each one of these points, look at it, they've got easting and northing components. And the last component, I showed you that in Civil 3D, which is the elevation, the height. If we can describe these three components, that will describe simply where that point sits on Civil 3D, on this empty space. So that will tell us what distance horizontally, what distance vertically, and you can see here we've got too many components. So this is the wrong description, that's why it's showing us wrong values here, because I haven't chosen the type of the value. You remember when I told you about PENZ, the point, and in fact I need PNZD, the point, northing, easting, height, which is elevation, description. So if I look at them now, point number 1 has a northing of 4,000 something, easting wherever. So look at them, these 2 points, they've got both positive values. That means they're all on the first quadrant. And we have elevation and description on the map. So when I import those, I'm waiting for the software to import them. So software is reading that data. It's a large Excel sheet, simple as that. And as you will see, all points were located in the first quadrant because all of them, they have positive northing and easting. So you understand now how the software usually deal with these points. So all these points to the software simply are coordinates. Each one of these points, if I select this point for example, has an easting, northing and height, elevation, all in meters. So that is what we call it polar coordinates, which is related to polar coordinates. How is it related? That point I was describing here, simply if I draw a line from the origin to that point, that line has a length and an angle. To find the northing, it's simply the line multiplied by cosine the angle. And if I want to find the easting, is the line multiplied by the sine of the angle. So if I give you 2 lines down the track and you need 2 points describing a line, and these 2 points you have the northing and easting for these 2 points, you should be able, theoretically, I'm not going to push you too much to do it manually. The software will handle all of this for you, but theoretically you should be able to understand how to relate these 2 points, either with the northing and easting components or with the polar coordinates, the length and the polar angle or the bearing angle. This will not be part of your quiz, just to let you know. I care about more how you can input this into the software, which is we will learn later on, and that you understand the concept. I'm not going to make you do all of these calculations manually. Now, if you continue reading on this, which is I'm not going to spend more time on the video, not to take too much of your time watching this video. If you continue reading here, that will explain to you if I have a line with a certain length and a certain angle, bearing angle. Don't forget this 65 degrees 0 minutes and 0 seconds. It's measured from the north, which is located somewhere here, an angle clockwise. How can I find the northing and easting? Simply all I have to do to find the northing, it will be that length multiplied by cosine the angle, and that will give me the value. So on the calculator, if you'd like, see if I can show you the calculator here. So let's do this for you. 100 times cosine the angle, which is 65 degrees, and that gave us 42.26. That's the one, the northing. And to find the easting, all I have to do, just change that to the sine of the angle. Okay, that will give you a value. Look, this is one way of doing it. There's other ways of doing it straight away from here, from the polar and rectangular coordinates. That's really not overly important for you. If you like, you can search it. We're not going to spend time on it because the software will handle all of this for us, and I don't want you to spend more time with this. Okay, I've got a few other examples here for you how to do them. We've got a longer example at the end, and that's something just for your own reading. You don't have to worry about calculating these numbers or how do we do them. This is just if I have a traverse like this, for example, not necessarily to be exactly this one, but let's say I have a traverse like that, and I have, let's see, is that the same traverse between A and B? That's 2, 3, 4, 3, 19. There we go. So this is the traverse here, and we gave you the length and polar coordinates, or the bearing angle for each one of these lines between A and B, B and C, C and D, D and A. And we are telling you point A has a coordinates, rectangular coordinates of northing and easting. When I'm saying rectangular, northing and easting of 0, 0. How can I find the other rectangular coordinates manually on paper? Why I'm not asking you to do this, because simply now you learned how to draw it on the software, and the minute you draw it on the software, you can easily just clicking on these points and find them, and I'll show you this at a later stage. But if you'd like to learn how to do it manually, simply for each one of these lines, we have to do the process of starting from one point, then to get to the other point, we have to calculate this, the same values what we've done, the length multiplied by the sine and the length multiplied by the cosine, and that gave us the change of northing or the change of easting. So what we do, we add that change to the previous coordinates. So if I have 0, I'll do 288.6 times cosine this angle. That will give me the north, plus 0, that will give me the new north of the new angle. If I need the north of this angle here, I have to calculate the same components here, which is 226.98 times cosine this value. That will tell me the change of north from this point to that point. You'll find that change is negative because I'm going down. Okay, so when I found that change, I add it to the north of that point. That will give me the new north for that point. Regardless, as I said, I don't want you to worry too much about it. If you are interested about this for your own interest, please let me know. I'm more than happy to spend time with you individually to understand those. The important part for me, that we understand the difference between polar and rectangular coordinates. Polar coordinates described with a length and a bearing angle. Rectangular coordinates described with northing and easting components. That will conclude it for this lecture for the starting foundation of our survey drafting techniques. The next one I'll be talking briefly about longitudinal alignment, and we start with some surface design and road design of the software, actual software design. Thank you.